Hello. Today we're learning to simulate waves, traveling waves in Python. So let's get started. So open your code editor, make a new Python file. Okay. So we first import a bunch of things. Now so we want the figure that we'll be plotting on. We want the so we add an axis so that we can control to clear the axis after a certain amount of time. We create a linear space to plot things on. This is the amount of, or whatever, it's minus pi to pi, and there are 10,000 different individually spaced or equal space between each of those numbers from minus pi to pi, 10,000 of them. C0 equals 0, t equals. So initial time, the increment of time for the animation, and now set the wavelength, frequency equals 1, amplitude equals 1, k equals 2 times pi divided by the wavelength. We're doing kx minus omega t cosine, so that's why the pi is there. wt equals 2 times pi times frequency. Def, so we define our function that we're going to use. And we need the numpy cosine, not the math cosine, because this is a lin space, the x. So, that we're going to pass in later. So now we prepare our plot for the animation. This is pretty self-explanatory. You do the function of the lin space at the specific time. You increment the time, and then you append it to the values. So it tells you at every single point in space at that specific time, and then you append that to the values. Now, we have one more function we have to do. So this k has to be global. This is a value that we need. We clear the axis, and then this we'll need later. For each value in the lin space, we plot the respective value of x. We want there to be a grid. Then we set the y limit -2 to 2. And then this is unnecessary, but we'll do it anyway. X limit minus pi to pi. Now, finally, we set our animation on the figure. Animate is the function we call for the animation over and over again. This doesn't matter. You can do it anyway. This just it passes in the numbers 1 through 360 into this I, and then the interval 20 milliseconds between frames, and then we show the plot. And then let's run this and hope it works, and if it works then we're good, I think. You can look in the description for more details, I guess. See, so it plots the wave at every point in space for a certain amount of time. I put in 50, but we could make it longer. We could make it 100. And it's a traveling wave, so it's this kx minus omega t. And notice how the minus makes the wave move forward. That's important, because it's sort of like telling, well, there's some math you could do that could show that. Okay, we can make it for a little longer if we want. This is 100 instead now. It's kind of cool. Okay, that's pretty much it. I hope you enjoyed.